Good morning and welcome everyone to Advanced Math class. I think this lesson calls for some discussion, so let me go through this with you. Hopefully it goes really easily and you find it to be not too challenging, but I know these, especially this first half, this factorable expressions, have been making some of you stress out because I didn't actually explain it back previous lessons. Okay, for the present, they point this out, and this is important to get kind of a starting point. For the present, these problems are puzzles whose solutions have no immediate application, but will be of great value in the future. In other words, we're just playing games to learn about these relationships. Right now, these problems don't have any direct relationship to real life, but they lay the foundation for a lot of powerful stuff we'll do later on. So this is just learning some basic skills. This is like scales in piano. Okay, occasionally people play scales in a song, but you don't just say use scales. Or push-ups in a football game. Nobody uses push-ups in a football game, but it preps you for it. It's that kind of thing we're doing, okay? Okay, so we look first at this one. Sine of x minus sine of x times the cosine squared of x, and they want us to show that that's the same as sine cubed of x. So the first thing we're going to do is factor. Now you'll notice there's a sine x in both terms on the left, so we can factor out a sine x. And what's left then would be 1 minus cosine squared x in the parentheses, okay? But we know that 1 minus cosine squared x equals sine squared x. And you might ask me, how do I know that? How I know that is the very important equation from the one lesson that I didn't teach you guys that this is built on. Sine squared plus cosine squared equals 1. And that's from basic unit triangle. If you go back to your unit triangle, sine squared plus cosine squared equals 1. Subtract cosine squared from both sides, and 1 minus cosine squared equals sine squared. So the parenthesis can be replaced, and that would be sine squared, okay? Now sine times sine squared is sine cubed. All done. The key to that, number one, is seeing the factoring in the first step. Number two is seeing that relationship, sine squared plus cosine squared equals 1, is an extremely important equation. It's going to be really, really important to you, especially as you go into calculus next year. In geometry context or trigonometry context, that equation, sine squared plus cosine squared equals 1, is extremely important. Okay, really looks like fun. Secant to the fourth power minus tangent to the fourth power divided by the secant squared plus the tangent squared. All that fraction plus the tangent squared equals secant squared. Check in your textbook if that looks weird to you. Pause this, get your textbook open. It may look a little bit more normal-ish in the textbook. I had a hard time getting it onto the screen without taking a lot of time to create stuff. Okay, that top part, the numerator of the fraction is secant to the fourth minus tangent to the fourth. You need to be able to see in that a difference of two squares. And then, this is really kind of hard to see perhaps, it's just there's so many pieces. That first part inside the curvy brackets, that's secant squared minus tangent squared, secant squared plus tangent squared, okay? That is difference of two squares. Remember, so squared is fourth, and it's the difference of the two because one is positive, one is negative. The middle term disappears. Now, if you can see this, you're going to be able to cancel the secant squared x plus tangent squared x. You can see that on the numerator and the denominator both have that term, which leaves us with secant squared minus tangent squared plus tangent squared, which equals secant squared. And obviously, tangent squared minus tangent squared is 0, so you just get secant squared equals secant squared. This one, once you factor that first step, everything else is actually fairly straightforward, or at least it should be. But that first step of seeing these being something to the fourth power because they're so complex things, and the fact that it's a fourth power than a squared power can really be confusing. But if you see that, then the rest of the steps actually come out fairly straightforwardly. If you feel like I'm doing these too fast, feel free to go back, adjust the speed on it if you need to, listen to it a couple of times, see what you do. Okay, cosecant squared x minus 1 over tangent x equals cotangent cubed x. And they point out that this time factoring won't help. And they actually do the factoring in the book to show you that it won't help. I didn't. But what we do remember is that the cosecant squared minus 1 equals cotangent squared. Now, back on that lesson that I didn't teach you about sine squared plus cosine squared equals 1, if you divide sine squared plus cosine squared equals 1, and you divide that by the divide that by the sine squared, you end up with and I can't do it in my head. 1 plus the cotangent squared equals the cosecant squared. Subtract 1 from both sides and you get this equation. That equation is a second powerful one. You take that basic equation, sine squared plus cosine squared equals 1, and divide it by either the sine or the cosine, and you get two more equations that are really powerful and very useful in these kinds of situations. So cosecant squared x minus 1, which is the numerator of our fraction, equals cotangent squared. So now we have cotangent squared over tangent squared. Okay? Which, if you think about it, is the same as cotangent squared times 1 over the tangent squared. Or tangent, excuse me, not squared. Because it's the same thing. If you multiply what I have in that third line together, you're going to get what's in the second line, main lines there. But then 1 over the tangent of x is the same as the cotangent of x. Cotangent of x is the reciprocal of the tangent. So 1 over tangent is cotangent. And cotangent squared times cotangent is cotangent cubed. Couple of key things there. First one is that major equation that I'm telling you really need to know. You need to get this memorized. If we were in class and you go, but I don't get these, and I said, have you memorized it yet? And you say no, then that's where we are. This is something you just have to get it in your head. Now, if you remember sine squared plus cosine squared equals 1, you can either divide by the sine or divide by the cosine, and you'll always get this. Don't technically have to memorize it, just have to know how to get it. And then remembering that tangent of x in the denominator is the same as the cotangent. And then it comes out. So these games can be a lot of fun, folks, both positively and negatively, depending on how you do them. Okay, second half of this lesson, we are going backwards. We have been looking at a graph and been writing equations. Now they're going to give us the equation and ask us to make the graph. Okay? So let's do this. And it's right at the top of the screen there, but that's okay. We're going to take up every inch of space here in order to do this. So we have this y equals negative 10 plus 2 sine 3, parenthesis x minus 45. There should be a degree sign there. Okay, so the center line is negative 10. Okay, we remember this. This is when we did these from the graph, we would look at the center line to find out what number went there. Now we're going the other direction. Can't remember which one of you is doing this, but one of you keeps switching the negative 10 and the 2. So watch that. The first number is what we're adding to the equation. We're sliding it up and down with that first number. In this case, we're sliding it down. Now the amplitude is 2. Okay, the number in front of the sign, that's the amplitude. That tells you how far it goes up and down. So with amplitude 2 means it goes up and down 2, which means from negative 10 you go down to its negative 12, you go up to its negative 8. Now please notice these are not axes. These are just dotted lines. These are not axes, and there's a reason why they're not. So don't get yourself, the dotted line isn't necessarily significant, except do keep track of this. These are not the axes. All these are reference lines, okay? All right. Okay, this is our basic sine wave or cosine wave. They look exactly the same, except for where they start, so you can just put it in there. I had a hard time getting, well, I didn't. These are hard to draw, and so I was able to find a graphic, and it's not perfect, but anyway. Okay, the phase angle is 45 degrees to the right. If you look up there, x minus 45, that's 45 degrees. It's negative, so it's to the right. And sine always starts at 0, okay? So that means we're going to put our 45 degrees there at y, okay, at 0, at the middle, okay? Sine starts in the middle, which would be 0 in a normal sine wave. It's been shifted down 10, so it's negative 10, but it's still our center line. So sine starts at the center line, and that's 45 degrees to the right, positive 45 degrees. So we're just going to put it there. Now do you see why that's not an axis? The axis is somewhere along there, and you can figure it out, but we're not going to. Now, the period is divided by 3. You notice the 3 in front of the parenthesis, in front of the x. That tells us what we're dividing our period by. This is going 3 times as fast as normal, so instead of taking 360 degrees, it only takes 120 degrees. So the period is 120 degrees. One complete cycle will take 120 degrees. Now, one complete cycle in 120 degrees. We're starting at 45 and going 120 degrees. That's 165. And that's one complete cycle. And so it goes up and down and back up again. And that's one complete cycle. And that's at 165 degrees. Okay? So we have the center line is negative 10. It goes up and down 2. Then you're noticing what I'm marking here. This may not match the book exactly, but this is what I want you to have marked because this will tell me you know what you're doing. And some book may do other things, but this is important. This is the parts of it that are important. The phase angle is 45 degrees. That means it's been moved over. It's going to start at 45 degrees. So you find the starting point of the sine and mark that 45 degrees. The period is 120 degrees because it's divided by 3. There's a 3 there. It's going 3 times as fast as normal. It only takes a third as long to get where it's going. So 360 divided by 3 is 120. And then you just go from 145, you go 120, and get to the next point. All right, let's do another one. Sketch y equals -2 plus 4 cosine 2, parenthesis x plus 2 pi over 3. Okay, 2 points, folks. Number 1 point. This is cosine instead of sine. Number 2, this is in radians, not degrees. Otherwise, very similar. So the center line is -2. That's where we're going. That's our center line. It's not an axis. It's just our center. The amplitude is 4. It's plus 4. So the amplitude is 4. Which means it goes up and down 4. So it's going to go down 4 would be -6. Up 4 would be 2. So that gives us our vertical line. Now again, it's not an axis. That's why it's dotted there, because it's not actually an axis. But then we can draw our sine wave, or a cosine wave in this case. See, it looks exactly the same, because the only difference between sine and cosine is sine starts at 0 and cosine starts at the top. Now this is shifted 2/3 of pi to the left. And you can either write that as 2/3 pi or 2 pi over 3. It doesn't make any difference. I'm going to write it both ways. So 2/3 pi or 2 pi over 3. It's shifted to the left because you'll notice it's positive. So that means it's to the left. And since cosine always starts at the maximum or at the top, we're going to mark that point 2 pi over 3. Okay, so that's the peak there is at 2 pi over 3. Now the period is divided by 2. See the 2 in front of the x. So we're going to divide the period by 2. It's going twice as fast, only going to take it half as long. But we're in radians. 1 complete cycle in radians is 2 pi. 2 pi radians per complete circle. Divide it by 2 and you get pi. So you just got 1 pi. It might be apple pie or pecan pie. It's just 1 pi. So 1 complete cycle in pi radians. So we start at -2/3 pi. We add 1 pi. And if I did my math right, we get 1/3 pi. So the second height peak is going to be at 1/3 pi, which is right there. So the second peak, first peak is at -2/3 pi. Second peak is at pi over 3. Now we could add numbers all along there. We could. And if you want to do that, that's, I'm not going to stop you. But we don't need to do that, okay? So text me your favorite kind of pie. And hopefully that helps you with your lesson. Hopefully you can get these. If not, of course, you'll let me know on Discord, and that's wonderful. But we'll talk to you later, and looking forward to hearing about your pie.